So example number 3. The equation of a body performing a simple harmonic motion is given by d squared x over dt squared plus 4x is equals to 0, given that when t is 0, x is 5 and dx over dt is equals to 0. Solve for x using Laplace transform. You will told to solve for x using the Laplace transform. So how do we solve for x using the Laplace transform? Are we together? Now, when you look at these initial conditions are the first ones you deal with. Are we together? If you look at this equation, x is a function of t. Okay? So if x is a function of t, it can be written as x is equals to x of t, meaning x is a function of t. So if you look at the initial condition, x is 5 when t is 0. So they are telling you when t is 0, x is equals to 5. Meaning this initial condition when t is 0, x equals to 5 can be written in this form. X of 0 is equals to 5, meaning when t is 0, x is 5. Are you seeing how it is expressed? If you go to the next initial condition, when t is 0, dx over dt is 0. So dx over dt means you are differentiating this x with respect to t, meaning x prime is just x prime of t. So dx over dt is x prime of t. So it means x prime when t is 0 is also 0. So this is the shortest form of representing those initial conditions. Are we together there? Those are the shortest form of representing those initial conditions here. So if you look at here, we only have the second derivative. So you are coming, what is the Laplace transform of d squared x over dt squared? The Laplace transform of d squared x over dt squared we found was s squared. Remember, x is a function of t, meaning x is our dependent variable. So it is s squared Laplace transform of x, isn't it? Then minus s, then minus x of 0, isn't it? Then it is minus x prime of 0. That is the Laplace transform of d squared of x over dt. After getting that, you now go to your original equation, which is this, meaning you introduce Laplace on both sides of the equation. So we are going to get the Laplace of this first term is going to be the Laplace transform of d squared of x over dt squared. Then it is plus 4 is a constant you factor outside. Then the Laplace transform of x to be equals to Laplace transform of 0 is just 0, isn't it? Yes. So from here, the Laplace transform of d squared x over dt squared we found from integration by parts to be s squared Laplace transform of x minus s x of 0 minus x prime of 0. So the whole of that is the Laplace transform of d squared of x over dt squared. Then it is plus 4 Laplace transform of x to be equals to 0. So here you collect the like terms. Where you have x of 0, you put the value of x of 0. X of 0 is 5. So x of 0 is 5 and x prime of 0 is 0. So you are collecting the like terms. S squared Laplace transform of x and plus 4 Laplace transform of x will be what? It will be s squared plus 4 in bracket Laplace transform of x. You've collected these like terms together, isn't it? Then you see minus s with x of 0. X of 0 is what? X of 0 is 5. So where you have this x of 0, you put 5. So it is minus x into 5, isn't it? Then it is minus x prime of 0. X prime of 0 is what? Is 0. So it is minus 0, which is not just 0, it's equals to 0. So you take this constant term the other side, minus 5s, isn't it? Are we together? So we are going to remain with s squared plus 4 Laplace transform of x is equals to 5s, because negative s times 5 is negative 5s. Negative 5s going the other side of the equation, it becomes positive 5s, isn't it? So you divide both sides with the coefficient of the Laplace transform of x which is s squared plus 4, s squared plus 4. So in the end, you get Laplace transform of x is 5s over s squared plus 4. So what do here? For you to get x, because x is what we are looking for, the particular solution, isn't it? So you take Laplace the other side of the equation, it becomes the Laplace inverse, isn't it? So we get x is the Laplace inverse of 5s over s squared plus 4. So if you have 4 is the same as 2 squared. Why are you writing in that form? Because if you look at what is here, when you have s over s squared plus this, that it means what? It means you have the Laplace inverse of, s over s squared plus a squared, isn't it? What is the Laplace inverse of s over s squared plus a squared? That one we found was cos at, isn't it? That was cos at. So it means cos 80. So it means in the numerator we must remove this 5 outside. 5 is a constant. So this 5 constant goes outside. Are you seeing that? 5 constant comes outside. So if you have this, you take your 5 constant outside. So you are going to have 5 cos 80 when a squared. So what is your a squared? A is 2. Are you seeing that? A is 2. So it is 5 cos 2t. So in the end, you get 5 cos 2t. Because you knew very well here, you have 5s over s squared plus 4. 5 is a constant, you factorize out. You remain with the Laplace inverse of s over s squared plus 2 squared. But you know that is s over s squared plus a squared, which is the Laplace. If you take the Laplace inverse, meaning it is exponential, it is cos. It is cos 80. Meaning if you look for the Laplace of cos 80, you get this. If you look for the Laplace inverse of this, you go back to your cos 80, isn't it? You remember this a squared, so it means your a is 2. So you get the final answer, the particular solution x to be 5 cos 2t using the Laplace transform.